Hello, we are Group 5 and our project is titled Automated Red Team Emulation for APT3, which is also known as Gothic Panda. Our project consists of two parts. The first part is the creation of multiple automated APT3 attack scenarios through the use of Python scripts, and the second is demonstrating how to detect those attacks through the use of a security onion setup. Our project is aimed at creating a system that could detect patterns and activity that resemble those of advanced persistent threat attacks. Each technique of those attacks will be automated through Python scripts we create and push onto a victim environment. Our victim environment consists of two Windows client machines and a Windows server machine in order to mimic a small work environment in a feasible manner. Then we have our attacker domain, which is equipped with Ansible to push those scripts to the environment. So far, we have managed to have the server domain, the client domain, and the attacker domain up and running with their virtual machines. And we have also created the security onion machines to detect the attacks. For the scripts, we have managed to finish the initial discovery and persistence phase, along with the gaining privilege, defense evasion, and accessing credential phase, and some of the discovery, lateral movement, and collection phase of the first scenario. I am now going to pass on my partner Ilya to explain about our network topology.
Thank you, Shadi. We're now going to show you the network diagram that we've updated since the last time. So as we can see, we've reduced a couple of VMs and also reconfigured the networking for our entire test environment. For instance, we've reduced the amount of Windows servers from 2 Windows servers to just 1, and also reduced the amount of security onion forwarder nodes from 2 to 1. This is so that we can save up on host resources in order to handle all of these VMs. Second of all, as you can see, we've started using OpenVPN in order to connect our remote hosts together. Particularly, we've made it so that our gateway VM is the OpenVPN server, and we've made it so that these client machines and these security nodes are connected through a OpenVPN tunnel. That way, they can share resources and send traffic to each other in order to make this test environment work. Now I'm going to send it back to Shadi, who's going to talk about the server and client domain.
As Ilya previously mentioned, we have two client machines running a Windows 10 operating system and a security onion forwarder node, all of which are connected to the server machine that is equipped with Windows 2012 Server through the use of a LAN segment. Each of the clients and the forwarder node will have three network interfaces, one for the LAN segment, one for the bridge interface, and one for the VPN. The server will only have the one network interface connecting it to the LAN segment and will be kept away from the internet, as in it will have no internet access. The server has been equipped with Active Directory and file sharing services, and the clients have been added to them. We have created the domain for the service and added both clients to that domain, as you can see in the photo here. And as I mentioned, they are in the Active Directory and are able to share files with one another. Here you can see that the client machines have access to the gateway VM through the use of VPN, and you can see that they are getting internet access through that gateway. Also, I have attached the picture including the IP configuration of one of the clients to further explain each network interface and its purpose.
So now we're going to be talking about the CentOS 8 Gateway VM, which is our central gateway for our test environment. So as we can see here, we have four separate interfaces that we're going to be concerning ourselves with. We have the first LAN segment designated VLAN 1, which is connected to our security onion management node. We have a second LAN segment designated VLAN 3, which is connected to our Kali threat agent VM. In order to get internet, we have this gateway VM directly bridged to my host's Ethernet adapter, which as a result will directly give this VM and all the other clients and other machines that need internet access. Finally, we've made it so that this VM has an OpenVPN server running on it, and it's running as the gateway for any other VM that's connected to the VPN. Therefore, it's designated as 10.801. And as a result, we've also made it so that the routes allow so that any clients connected to the VPN server will be able to access the private LAN network that is for the clients and the server domains. Next, I'm going to be showing you the IP table rules. As we can see here, it's just set to the default IP table rules that is made by CentOS 8, except for the ones that are added by the OpenVPN script that I've used to create the OpenVPN server. However, what we've added is that we're dropping any forwarding traffic sent from the threat agent to the bridge interface. That way we can prevent the threat agent VM from accidentally sending any unnecessary packets or the scripts that we've intended to outside our test environment, and therefore keeping this test environment airtight. We've also allowed it so that other traffic from the clients and the security nodes are allowed to be masqueraded and forwarded from the bridge interface, therefore giving them internet access. Here we're just showing that the OpenVPN server is up and running on our gateway VM, and that the other VMs are able to connect to it directly. Moving on, we're going to talk about the threat agent virtual machine. We're going to be talking about its IP address configurations and any connectivity tests that we've done so far. So as shown before, previously it's on a LAN segment with the CentOS gateway machine. It's designated at VLAN1, and it has the IP addresses 192.168.80.2/30. We've installed packages Ansible and SSH on this machine in order for us to send the scripts remotely to our victim domain via Ansible, and also have SSH installed in order to for test purposes to connect to the other machines. We've also proven that this VM cannot access the internet, and it cannot ping the security onion nodes at all, therefore not accidentally targeting them with our scripts. However, it can still connect to the victim nodes, or sorry, not victim nodes, the victim VMs, and also their LAN segments that we have specified in the IP table rules in the gateway VM. As mentioned before, our Kali machine has also installed Ansible and SSH on it in order to maintain connectivity to the victim domain for test purposes, and as well as to send the attack scripts remotely. Finally, on my end of the test environment, we'll be talking about the Security Onion Management node, which at the moment has internet connectivity as well as connectivity to both the CentOS Gateway VM and other Security Onion nodes, such as the search node on Yasim's side.
Thank you, Ilya. Now I'll be talking about the attack scripts. So a list of completed techniques that we have done so far are T1005, T1059, T1057, T1069, T1083, T1087, T1098, T1105, T1110, T1136. Okay, so now I'll be talking about T1136 and T1198. So according to the Red Team Automation GitHub repository, this script creates a user with net.exe. So it covers technique number 1136 and 1098. So here we can see a bunch of lines that add user support to a domain called REA705, and the full name for that user is Shadi Jaffrey. Here we also see that we use the net command to add administrators into the domain as well. Next one is T1005, which collects Microsoft Office files. and it scans the system for Microsoft Office documents, copies them and compresses them into an encrypted file, or rather a RAR file. So this script I wrote myself. I import the OS library, create a variable, and then using the os.system, I invoke the command called PowerShell.exe, excuse me, and then get child item commandlet is basically listing all the directories that are currently on the system, and then treef command is used to list all the directories and subdirectories that you're looking at currently and with the files. Now I'm going to talk about security onion search nodes. Um, search node 1 is connected to OpenVPN, as we can see on the right hand side, and we see that the initialization sequence is completed, whereas search node 2 has issues starting OpenVPN service after it has been downloaded and installed. Now, looking here, we have that issue that I mentioned just a few seconds ago, that I tried to start OpenVPN on search node 2, but for some reason it will not start at all and it will just throw an error. So we're gonna try and work our way to troubleshoot that issue in a timely manner. So as mentioned earlier, OpenVPN fails on certain security onion nodes after downloading, and configuring security onion search nodes and forwarder is another issue. And then there are certain techniques which are quite challenging and which may throw us off, but we will try to keep ourselves ahead and try to be able to get those technique deliverables done in a timely fashion. Alright, so thank you so much for your time in this presentation. I hope you liked the presentation.